Dalgaları karşılayan gemiler gibi gövdelerimizle karanlıkları yara yara çıktık. Rüzgarları en serin, uçurumları en derin, havaları en ışıklı sıra dağlara. Hey, hey, hop, hop, hey, hey, hop, hop, hey, hey, hop, hop. Dostların arasındayız, güneşin sofrasındayız. Dostların arasındayız, güneşin sofrasındayız.
Good morning, everybody. Today I'm going to talk about total organic carbon and conductivity in pharmaceutical grade water systems. The content of my presentation will cover conductivity, TOC analysis, a bit about validating a TOC analyzer, and then I will talk about one of the instruments we have brought with us here today, which is on the table over here, PAT 700 TOC analyzer. So first of all, some talk about conductivity. Can you hear me okay? You can hear me? Yeah. Okay, so conductivity measurement in a water system is effectively a measurement of the ionic activity in the water. Compounds, when they're dissolved in water, will dissociate and break into their ionic form depending on how much energy you put into the water system. So these compounds are breaking into their ionic form and recombining again, and when they are in their ionic form, they can allow the water to carry an electrical current, and that's how we measure conductivity. So for instance, sodium chloride is made up from, of course, Na plus and Cl minus in their ionic form, and these can carry an electrical charge in the water. The more energy you put into the water in heat, typically, the more these compounds will tend to break into its ionic form. And as I mentioned, they then contribute to the conductivity of the water. Some substances dissociate, come apart very easily and more readily than others, and they're very reactive chemicals. So acids, alkalis, very reactive because they dissociate very easily and they react very strongly. So we have different materials in the water, different compounds. Each will dissociate sometimes easily, sometimes harder. So the conductivity measurement of the water is dependent on the chemicals in the water itself. So when you are measuring conductivity, you need to understand what is in the water to make the measurement correctly. So a conductivity meter will measure these ions as they go through the water, and they carry an electrical current in the water. So this dissociation is the key factor. I mentioned to make a compound break down, you need to put energy into the compound. Typically this would be heat. So in a water system, the hotter the water, the more conductivity you will see. So if we looked at temperature versus conductivity, the more energy, more temperature you put in, the more conductivity you will see. Now, in pharmaceutical grade waters, just before the year 2000, we had an issue with measuring conductivity in pharmaceutical grade waters because each manufacturer of a conductivity meter would have a slightly different temperature compensation slope built into the analyzer. So you would select the temperature compensation according to what you think was in the water. So you can have 2 or 3 conductivity analyzers next to each other on the same water system, and they will give you a different answer. Yeah? So what they decided to do in the pharmacopoeias is make all of the analyzers report conductivity without compensation. no temperature compensation in the conductivity analyzers. So what you'll see in the pharmacopoeias is they will give you a table like this. It'll tell you the allowable conductivity for your water system according to what temperature your water system is running at. So the pharmacopoeia now says you will run the conductivity analyzer without compensation, no temperature compensation, and then you use the lookup table here, defined in the pharmacopoeia, to see if your water is within specification. Okay, so that was conductivity. Now to total organic carbon. The reason I talked about conductivity is because in the typical TOC analyzers that you will see on a pharmaceutical grade water system, they are effectively conductivity meters. All the TOC analyzers use conductivity to measure organic carbon. I'll explain how they do it in a minute, but effectively they are temperature compensated conductivity meters. So what happens inside the analyzer we have over there is the analyzer takes a sample of the water, it captures it in the measurement cell, and then it measures the conductivity. So that conductivity is all the inorganics in the water, any dissolved salts. So it takes that baseline conductivity. And then what it does is it turns the UV lamp on. The UV lamp puts energy into the water and it breaks all of the organic materials down into their constituent parts. And eventually they come down to carbon dioxide and water. The carbon dioxide dissolves into the water and then increases the conductivity. So now we have more conductivity, and by measuring the difference in that conductivity between the start and the end, we can then tell you how much organic material there is in the water system. So first of all, as I mentioned, we capture a sample of the water, we measure the conductivity. Then we turn the UV lamp on, that oxidizes all the organic material down to carbon dioxide. That carbon dioxide contributes to the conductivity, and we see the conductivity increase. When it finishes changing, then we know that we've oxidized all of the organic, and that change in conductivity is directly proportional to the amount of organic carbon in the water. So you see, conductivity is the fundamental measurement we're doing with these TOC analyzers. They all the TOC analyzers that you see on a pharmaceutical grade water system will use conductivity. Now, because we are breaking the organics down to carbon dioxide and then measuring that change in conductivity, it's important that we completely oxidize all of the organic material to make that measurement. Until recently, all of the pharmacopoeias stated that we should oxidize all of the organic material completely, which is obvious because how can you measure it if you don't oxidize it? So the United States Pharmacopoeia said that we should share the objective of completely oxidizing the organic molecules. The European Pharmacopoeia says the same thing, we should completely oxidize it. Now the TOC analyzer you can see over there was specifically designed by Antony to meet these objectives. So it captures an aliquot of water and it completely oxidizes it. So this is the only TOC analyzer on the market that does that. So if you're looking to comply with exactly what it says in the pharmacopoeias, then this is the analyzer to use because it is the only one that can guarantee you've oxidized all of the organic material to carbon dioxide. And the way it does that is it looks at the conductivity as the conductivity changes, and it waits till the conductivity stops changing, and then it says, right, I've finished the analysis, and it gives you a result. So sometimes when you're breaking these organic materials down, they break into an intermediate species, like an organic acid or something like that. This organic acid contributes very strongly to the conductivity. But then as it's broken down to carbon dioxide, the carbon dioxide does not contribute to conductivity as strongly. So you see this pattern as it goes to the intermediates in the organic acids, and then it breaks down to carbon dioxide. So it's very important to complete that analysis, otherwise you will get a wrong result. So let's take a look at validating a TOC analyzer. First, of course, when you're validating, you need to make sure that the instrument that you're using meets the user requirement specification, obviously. Then you need to make sure it's installed correctly. You need to verify the calibration. Sometimes you will perform a calibration on site. Now remember I said that all TOC analyzers used in pharmaceutical water are conductivity analyzers. So we need to not only verify the TOC, but we need to do the conductivity and the temperature sensor. System suitability, I will talk about that a bit later. And of course, any signals 4 to 20 milliamp or serial connections to remote systems need to be verified. And then, of course, you go into the performance qualification stage. Now, really what we're looking for here is to make sure that the analyzer will reliably perform its job over an extended period. Some TOC analyzers require a lot of frequent calibration. Others, you can extend the calibration period, and you do that using the performance qualification. So first, let me look into these aspects of the analyzer. First of all, we demonstrate that the user requirement specification, the requirements for the analyzer, are met through the installation, qualification, and operation qualification. Then, as I mentioned, the performance qualification will allow us to establish the frequency of recalibration for this analyzer. So first we look at the commissioning, and then we would start to look at stability over an intensive period of weeks, and then we push out to 6 monthly testing. Ideally, we want an analyzer which will have 6 months or a year stability. We don't want an analyzer where you have to keep going to it each week to change reagents or to recalibrate it. So let's take a look at verifying the calibration itself. As I mentioned, the TOC analyzer based on conductivity. Now typically in the factory, when these analyzers are made, there will be a very thorough calibration performed, typically between 1 ppb of TOC right up to 1000 ppb. This needs a specialist water treatment system that allows us to control to very low levels. So we do that in the factory. However, on site, once it's installed in your factory, what we do on site is a 3-point calibration, 3 points. So your water system, a modern water system, typically 30 parts per billion of TOC, very low. Sometimes I've seen 7 or less than 10 ppb. So your water system is operating very low, but what the pharmacopoeias tell us to look for is no more than 500 ppb, which we heard from the last speaker. He said the limit, 500 ppb for TOC. So what we do with calibration on site is we have 3 calibration standards, and we bracket the 500 ppb. So the first standard is a 500 ppb standard, the next one is 250, and the one above is 750. In this way, we've actually bracketed the 500 ppb point. We don't really care if the analyzer is very accurate at these low levels. We want to make sure that our water system is in compliance, and that's the 500 ppb line. So we need to know the analyzer is extremely accurate around the 500 ppb level. The other issue we have with calibrating on site is getting a TOC standard that's stable below this sort of level is very difficult. So we cannot really make standards to this level. It's just almost impossible to have stable standard. So we can provide standards for the analyzer. These are the three calibration standards I mentioned. We can also provide system suitability standards. So these are made and traceable to pharmacopoeial starting materials. So, our analyzer's online, it's reporting TOC. We are using the water for manufacturing, we are releasing products, and then we come to look at the analyzer. It's come up for its calibration cycle. The first thing we want to check is that the analyzer has been working correctly since it was last calibrated. So the first thing we do is an as-found calibration. We check the analyzer by running through certified standards to make sure that it is still within calibration and still working correctly, because we've been releasing pharmaceutical product based on this information. The next thing we would do is a calibration of the analyzer, and the last thing we do is we do again a check to make sure that the calibration procedure we have just performed has worked effectively. So we check the analyzer was working when we find it, we calibrate it, and then we check it when we need to make sure everything is okay. In this way, we can be confident that the water quality in our manufacturing plant is going to be within compliance. Now, talk about the system suitability test. The system suitability test for TOC analyzers is really a performance check on the analyzer. What it's trying to establish is, can this TOC analyzer analyze the range of organic material that we will have in our water systems? So we test it with a very easily oxidized substance, sucrose, and then we test it with a difficult to oxidize substance, benzoquinone. And we test the two and we check to see that the analyzer will analyze both of these materials correctly. So we put into the analyzer, we put the sucrose and the benzoquinone. The analyzer does the test. First of all, it reports the sucrose, so we put in a 500 ppb standard. Now what's important here is that it has actually reported 475. It doesn't matter for system suitability. System suitability is not a calibration. So in many ways, the actual number that it reports is not important, and I'll explain that now. You put through the benzoquinone, you get a slightly different number. What is important is that those two numbers are very close together. We're looking at the effectiveness of this analyzer to oxidize these organic materials. We're not trying to calibrate it. So we look at the ratio of these two, and we want to make sure it's within an acceptable tolerance. So this analyzer will analyze all the organic material, doesn't matter what it is, effectively. So system suitability is a check on the analyzer ability to oxidize. As I mentioned, all these analyzers are conductivity analyzers, so we must verify the conductivity cell. We must check the electronic meter accuracy and also check the cell constant itself. And although I mentioned at the start that when we're measuring conductivity, we don't use temperature compensation, all TOC analyzers actually do. So all TOC analyzers will actually have a temperature sensor in them, and they have a compensation curve built into them. So it's important to verify the temperature sensor as well. So checking the temperature sensor, quite simply, you could use a certified calibrated instrument, measure the water temperature coming in, and check that the instrument itself is reporting the same temperature. For the meter accuracy itself, typically we would use a certified calibrated resistor for that. So we're checking the accuracy of the meter itself now. So we disconnect the connections to the conductivity cell, and we replace it with a certified calibrated resistor. So this resistor now will give us an accurate check on the meter to make sure that the electronics is interpreting the cell correctly. For the cell constant is a measurement of the size of the conductivity sensor and the distance between the plates. And the way we check that is by using a certified standard, a conductivity standard. We put it through the analyzer and then we say yes, it is measuring correctly according to the certificate of analysis supplied by the laboratory. Okay, so I'll now talk a little bit about the analyzer you can see over there. I'll be here for 2 days, so if you want to ask some questions, please come and see me. So this is the TOC analyzer manufactured by my company. The brand name is Antony, and this analyzer is specifically designed for pharmaceutical water. It is designed to totally oxidize all the organic material in the water system. It's the only one that's designed specifically to do that. It has an automated standards introduction system on there, so for calibration and system suitability, you can load the standards, press a button, and walk away. The analyzer will automatically calibrate itself and then return to online. It has the standard operating procedures for all the calibrations, for system suitability. They are built into the analyzer. So you can go to the analyzer, you say, now I want to perform system suitability. You press the button, it leads you through step by step and what you need to do, and you press the go button and it does the analysis for you. So unlike the TOC analyzer in the quality control laboratory, where we have technicians, QC technicians on hand who are very, very knowledgeable about system suitability, calibration. Once one of these analyzers moves into the production area, typically the people carrying out these tests will be technicians and engineers. So having the built-in SOPs will help them walk through the process. They don't need the in-depth knowledge that a QC technician might have. It can report for you for your water system. It can give you a 4 to 20 milliamp output for TOC, temperature and conductivity. So this analyzer is not just a TOC analyzer, it will give you temperature and conductivity as well. Unique again to this analyzer, it has 2 UV lamps in the analyzer. As I mentioned, it uses the UV lamp to break the organic material down. So, as I mentioned, specifically designed for pharmaceutical water systems. The onboard standards introduction system, it saves time. As I mentioned, you load all the bottles for the system suitability or the calibration. You press the button, you walk away. These tests can take 1 hour or 2 hours to perform. So if you have to stand there and wait for the analyzer to say, next bottle please, and it's a lot of time taken up by just putting these standards through. Each of the standards bottles comes with a radio frequency ID tag. So when you load it into the analyzer, it automatically uploads the calibration. It checks that the standard is within date. It checks you put the right standard in the right place. So it really improves the confidence that when you perform a system suitability or a calibration, it improves the confidence that it's been done correctly. If a bottle is used, a standards bottle is used by the analyzer, as soon as it's finished with that standards bottle, it voids the RFID tag. So if somebody was to mistakenly use that bottle again in another analyzer, it would reject it. So there's a high level of confidence built into this analyzer to make sure we're doing the right thing. As a nice side effect from this, the grab sample ports here can actually be used for water samples from the water loop. So if you were doing some investigation on your water system to see on contamination levels, you can take samples from the water loop and feed them in through here. So it's not just an online analyzer, it will do grab samples as well. If somebody accidentally puts the standards in the wrong place or uses the wrong type of standards, the analyzer will read the RFID tag and it'll say, stop, you're using the wrong type of standards. So this, again, it reinforces your confidence that the analyzer has been calibrated correctly. So as I mentioned, this analyzer can be used for grab sample analysis. You'd load the grab samples into here, and then you would put their ID labels in here and perform the analysis. One thing that I've observed on water systems is that out of specification occurrences are often transient. Quite often you get a contamination from a point of use, Somebody turns the point of use on, a small amount is sucked back into the system, and you have a contamination event. That contamination in the pipeline will be a high TOC reading, but by the time it gets back to the storage vessel, which is a large volume of water, it'll be diluted down, and you won't be able to measure it. So this analyzer has an excursion capture system built into it. And what it will do is you're allowed to enter a TOC limit, which is your alert level. And then what the analyzer will do is if that limit is passed, it will take 2 samples from the water loop straight away into the analyzer. The first one it will analyze again to just check that yes, it is higher than this limit. The second one it saves. Now this means you can take that bottle back to your QC lab and do a bit more analysis on that water to try and find out where that excursion came from in your water system. Because the last thing you want to be doing is putting contaminated water into your expensive pharmaceutical product. Because then you've ruined your product and it's very expensive. So this helps us to do a bit more root cause analysis. The analyzer itself has an internal memory. To allow us to comply with the rules for data integrity, you can export the data onto a memory stick, but it's done in a secure manner. So the data is encrypted. I had a phone call, well, sorry, no, our technical support desk told me they had a phone call once from a company using one of our TOC analyzers, and they said, the data we have from the analyzer shows an excursion, an out of specification. Can we change the data, please? That's a bit of a scary thing. So, this analyzer is fully compliant with the 21 CFR Part 11 rule, which is all about data security. So the analyzer will put the data onto a USB stick for you, but the software encrypts it and holds it secure, so you can't manually change it. One of the applications that I've seen growing over the last few years is the use of TOC, not just for water quality online, but also for clean in place. So if you're cleaning your vessels down prior to reusing them, then TOC is quite a nice catch-all. It's a nice parameter which will catch a broad range of contaminants. So you can use it for your final verification that the cleaning of the vessel has been carried out correctly. This analyzer has a special routine built into it. So as I mentioned, it will measure conductivity and it will measure TOC analysis. So you can use the conductivity to measure the cleaning reagents and then use the TOC to measure the final cleanliness, to verify the cleanliness of the vessel. This analyzer can actually be used in the QC laboratory as well. There is an auto sampler that works with it, which will handle up to 36 vials. The attraction of using this analyzer in the QC laboratory is that there are no reagents, there's no process gases in this analyzer. So it's a very low cost of ownership for this analyzer. So the other bit of root cause analysis we can do with this analyzer, and that one on the table over there will do this for you, is so some of these models can be bought with 2 sample points. So here, if you look at the one that's on the table over there, you'll see there are 2 sample points on there. So what we're asked to do is to demonstrate that the water quality we're using is within compliance, and the sample must reflect the quality of the water we're using. So typically, what I've seen people doing is putting the TOC analyzer at the end of the loop. The argument is that the water quality then, any excursions will be captured by this. However, you have to then ask yourself the question, where did the excursion come from? If it came from the feed water here, if we monitored at this point, we'd know where it was coming from. If we measure here, it could be one of the points of use is taking a sample back into the water and contaminating it. So by testing at both points, this helps us to investigate any excursions we may see on our water system. So to support that, this TOC analyzer has 2 sample points, and it will test here and then there, and it will alternate between the 2, so you know where the contamination came from. Unlike the TOC analyzers typically I've seen used in the QC laboratory, this analyzer has a stable calibration period of up to 12 months. So you can calibrate it and leave it without any intervention for 12 months. And the way we do that is partly because it's a very stable conductivity cell, but also because it has 2 UV lamps. One of them is the main lamp, and the other one is a standby lamp. So what we do is we monitor the UV lamp over time. So if the UV lamp starts to fail, we automatically switch to the standby lamp. So you never have a gap in analysis. It sets an alarm for you and tells you that one of the UV lamps has failed, but you only need to replace it once every 12 months. So this analyzer will sit there on your water system, giving you reliable results for 12 months with no intervention. So, I'm finished. I'm sure you're pleased I finished quite quickly because I think we have lunch next. Any questions at all? No? Well, I'll be here for 2 days, so if you want to come and ask me, please do. All right, thank you very much for your time. Thank you.